Hello student, good morning. I am Dr.A.K Sinha, Professor of Chemistry. Today I am going to discuss oxoacids of phosphorus. Last class I have discussed allotrope of phosphorus. Also I discussed trichloride of phosphorus, means phosphorus trichloride, and also phosphorus pentachloride. Now I am going to discuss oxoacids of phosphorus. Phosphorus forms a number of oxoacids. Their important oxoacids with their formula, method of preparation, and the presence of some characteristics bonds in their structures I will discuss. There are around 6 to 7 you can tell oxoacids are there. Phosphorus has 7 oxoacids. 7. Then actually it is difficult to remember the name of phosphorus oxoacids, but I will tell some technique, then you will remember also and you can understand also, because 7 acids are there. Their name is somewhat similar. It is difficult to remember, but I will try to give some technique, then you may remember quickly. Then first I will tell the name of acids. Okay. Then first name is hypophosphorus acid. Hypophosphorus acid. Its molecular formula is H3PO2 and oxidation state of phosphorus is +1. First I will tell these things, oxidation state and molecular formula. After that other things I will tell. Then first acid I told you hypophosphorus acid. Molecular formula is H3PO2 and oxidation state of phosphorus is +1. Now I am telling you other acid. After the hypo, ortho is there. Hypo, ortho and pyro. These three term you remember. These three term. Ortho, pyro. Hypo already told you. Then these three term you remember. That is hypo, ortho, pyro. Correct? Because these three will be repeated for other three. This is the first technique how to remember. These three terms will be repeated for other three. Okay. And one term is meta. That will come in the last. That is the 7th, with 7th acid. Then first I told you hypophosphorus and second is orthophosphorus and third is pyrophosphorus. All three are phosphorus. Only difference is of hypo, ortho, pyro. Correct? All are phosphorus. Correct? Then hypophosphorus formula is H3PO2, oxidation state is +1. This oxidation state is of phosphorus in H3PO2 and second orthophosphorus acid. Its formula is H3PO3, 1 oxygen more. It was H3 is common in both, but here in ortho 1 oxygen atom is more, means H3PO3. H3P is common, only one this phosphorus is there in both. Both have one phosphorus and both have 3 hydrogen. H3P is common. Difference is in number of oxygen atom. First one is O2, second one is O3. And here oxidation state is +3, no +2, +1, and in second one +3. If you know how to calculate, many times I have just explained how to calculate the oxidation state. Anyhow, it will come +3. Third acid is pyrophosphorus acid. Then now here oxidation state is again +3 and formula is H4P2O5. P2O5 you know. P2O5 you know, phosphorus pentoxide. Only in that here is 4 hydrogen attached, H4P2O5. It is called pyrophosphorus acid. H4 you remember. Now in this third one it is a H4. You have started with this H3. Now with third one it is H4P2O5. Very easy to remember. And oxidation state is +3. Now next 3 I am telling you. Minor change is there. Name is same, hypo, ortho and pyro. But now phosphorus became phosphoric. There it was phosphorus, OUS, us in all 3. Now in this next 3 it will be ORC. Okay, means phosphoric, ORIC, RIC. Correct? Phosphorus become phosphoric. Remember, all 3 will be now, next 3 will be phosphoric. Then hypophosphoric, orthophosphoric, pyrophosphoric. And molecular formula, now you see. Here H4P2O6, H4P2O6. Okay, that is for hypophosphoric. For hypophosphoric acid, formula is H4P2O6. One extra P2O5 was there. Next is P2O6. And now oxidation state is +4. And next, that is for orthophosphoric. Then it is H3PO4. It is common. Phosphoric acid, what we are telling, that phosphoric acid, H3PO4. You remember, this is the common orthophosphoric acid. Generally it is called phosphoric acid. Then H3PO4, and in this phosphorus has +5 oxidation state. Now next is pyro. Then pyro here means again H is 4. H4 means this in out of 3 phosphoric, first one is H4 and third one is H4. Only in the middle it is H3PO4. That is ortho, common phosphoric acid. Now pyro is H4. Okay, H4P2O7. one oxygen more, P2O7, phosphorus heptaoxide. Phosphorus heptaoxide, P2O7, you know. P2O5, phosphorus pentaoxide, this is phosphorus heptaoxide. There H4 is attached, H4 P2O7, and oxidation state is again 5. Then this in phosphoric, first that is this hypophosphoric acid is +5, and other two are +4. First one is hypo is +4, hypophosphoric +4, and other two are +5. And last acid is metaphosphoric. It is also ic, means last 4 is ic only, but only that in with the last meta you have to use, metaphosphoric. Then 4 is ic, and first 3 is us. Okay, this is the difference. Then easily you can remember. Then in a sequence, if you will write, then you will find that last 3, including in ic, there are total 4. Then out of this 4, last 3 is oxidation state is +5. That you can calculate, no problem. Okay. Then this I have told about the molecular name, molecular formula, and this oxidation state. Now important things I am telling you related to these acids, that is the characteristics bonds and their numbers. How many, what type of bond is there, what are their number, that is a single, double, triple, like that. Then characteristics I will tell you, and shortcut preparation I will tell you. Okay, how will you prepare. Then first, for the first acid, that is for hypophosphorus acid, means H3PO2. How many bonds are there? I am telling you. Here in this H3PO2, one POH, one bond is there. Actually only one phosphorus is there. One phosphorus is there. Then here POH, one bond is POH bond, and two bond is PH, and third bond is PO. 3 types of bonds are there. First bond is POH, one POH bond, two PH bond, and one P double bond O. Correct? Now how will you prepare this? H3PO2 means hypophosphorus. Then just you take white phosphorus and add NOH, alkali. You will get this acid, means white phosphorus P4 plus alkali. You will get H3PO2. Now come to the, after the hypo, come to the orthophosphorus, H3PO3. Here for two acid, hypo and ortho, one more name is there. That is the hypophosphorus is also called phosphinic acid, PHINIC, phosphinic, that is for hypophosphorus. And for orthophosphorus, that is the phosphonic, also called phosphonic. Anyhow, now come to the bond. Then in hypo already told you. Now I am talking about ortho. Then in ortho, POH bond is there, but its number is 2. 2 POH bond is there, and one PH bond is there, and one POO bond is there. Means all 3 type of bonds are present in second also. means H3PO, H3PO3, H3PO3. Then difference is that now you have two POH bond. In this, two POH bond is there, and pH and two pH bond. Two pH bond was there in this things hypo. Two pH bond, one POH bond, and one POO bond. Double bond O. Okay, but now here two POH bond is two pH bond, and there two pH bond was there. Now here one pH bond is there, and one P double bond O. Okay, P double bond O is there. Now how will you prepare? Then it is very easy to prepare. P2O3 means phosphorus trioxide plus water. P2O5 plus H2O, you will get H3PO3. Okay. Now third is pyro. Pyro means pyrophosphorus acid, H4P2O5. Then here you will find two POH bond. Three type of bonds are here also, but their number is differing. Two POH and two pH, and two, that is the P double bond oxygen. PO oxygen is there, PO bond, but P double bond O, that is their number is 2. 2 P double bond O is there, PO. Then this I have told about the third one, that is pyro, means H4P2O5. Now how will you prepare? Then it is prepared by just PCl3 you take, phosphorus trichloride plus H3PO3. H3PO3 means orthophosphorus acid. PCl3 plus H3PO3, you will get H4P2O5. Now come to the fourth one. Now ick. Okay, phosphoric. I am talking about it started. Then first start with hypophosphoric acid. That is the H4P2O6. Okay, H4P2O6. Fourth one I am talking about phosphoric. That is the hypophosphoric acid. Then now here what you will get, this bond. Then now you can see here POH bond is there, but their number is 4 POH bond. Okay, 4 POH, and P double bond O means PO bond how many? Then 2. Remember 2. And PP bond here is a new, because here phosphorus is P2, H4P2O6, H4P2O6. Then here PP bond is there. Okay, before no PP bond was there. First time PP bond you have seen in this H4P2O6. This is the very important. One PP bond is there. Now how will you prepare this H4P2O6? How will you prepare? Means ortho this hypo this I told you hypo. Then hypo, how will you prepare? That I am telling you. Hypophosphoric acid H4P2O6. How will you prepare? Then it is prepared just red P4, red phosphorus plus alkali. Red phosphorus plus alkali, you will get H4P2O6. and white phosphorus you have seen in the first case. White phosphorus means P4 plus alkali. Here red phosphorus plus alkali means first one and fourth one both hypo. For that P4 you are using, but difference is that in first case, hypo case, white phosphorus you were using, here red phosphorus, but in both cases alkali you require. Now come to the orthophosphoric acid, general, H3PO, H3PO4, always remember this is a general phosphoric acid, orthophosphoric acid. Then here how many POH bond is there? P and OH bond, then 3, and PO bond, P double bond O, only 1, okay, only here only 2 type of bond is there, POH bond, 3 POH bond and 1 PO bond, P double O bond, only 2 type. And how we will prepare? Then P4O10 means dimer of P2O5, P4O10 plus water, H2O, P4O10 plus H2O, you will get H3PO4. Okay, now sixth one, that is the pyrophosphoric acid. Then here formula is H4P2O7. Remember, H2P2O7, not H4P2O7, H4P2O7. Then here you will find 4 POH. 3 type of bonds are there. POH bond, PO bond means P double bond O, and POP bond. Here again a new bond is there, POP bond. Okay. Then here 4 POH bond is there and 2 PO bond, P double bond O, and 1 POP bond. Okay, POP bond. How will you prepare it? Then you will get it simply by heating phosphoric acid. Phosphoric acid means orthophosphoric acid, H3PO4. Just to heat it, you will get H4P2O7. And then last is metaphosphoric acid. Metaphosphoric acid. Actually, this is the polymer. Polymer means a polymer of HPO3 whole N. HPO3 whole N. N may be 2, 3, 4, 5. Correct? It is a polymer actually. HPO3 whole N. This is called metaphosphoric acid. And what are there? This bonds. How many types of bond may be there? Then 3 types. All are 3. POH, 3 POH bond, 3 PO bond means P and P double bond oxygen, 3 number, and 3 number of POP. Correct? It is very easy to remember. All 3 bonds are 3. POP bond is 3 POP bond. 3 PO bond means P double bond oxygen. Okay. P and between P and O double bond is there. And 3 POH. And how will you prepare? Then it is prepared by phosphorus acid plus bromine, and you have to heat it in a sealed tube. Phosphorus acid, 3 phosphorus acid is there, any one you can take. Phosphorus acid plus bromine, and just heat it in a sealed tube. Then you will get metaphosphoric acid. Okay. This I have told you about these things, oxoacids of phosphorus. Now structure also I have told you, and I will try to send the structure also. Already number of types of bond and number of bond told you. Okay. The composition of the oxoacids are interrelated in terms of loss or gain of H2O molecule. This is important. The composition of the oxoacids are interrelated in terms of loss or gain of H2O molecules or sometimes oxygen atom. Because H2O, there is a gain or loss of H2O, then obviously there is a gain or loss of oxygen also. That's why R O atom you can tell. Then this I have told you about the orthophosphoric acid. One new type of acid is there, this oxoacids, that I am telling you, that is not new type. Only you can tell it is a metaphosphoric acid. But now N is equal to 3. It was whole N. If N is equal to 3, then that time it will form a just like a ring, cyclic. That's why name has been given cyclo tri metaphosphoric acid. Because it is metaphosphoric only, but it is in cyclic form. That's why you have given the name cyclo tri because N is equal to 3. N is equal to 3. That's why it is called cyclo tri metaphosphoric acid. Okay. And poly means already you know that many HPO3, if it is attached to each other, then it will be called HPO3 whole N. Then this I have told about the structure of oxophosphoric acid or oxoacid of phosphorus. Now further I want to tell you, in oxoacids, phosphorus is tetrahedrally surrounded by other atoms. This is an important point. Question is asked. In oxoacids, again I am telling you, in oxoacids, phosphorus is tetrahedrally surrounded by other atoms. All these acids contain at least one P double bond O. PO bond is there, then double bond is there between P and O, then at least one PO bond. All acids will have at least, all these acids contains at least one PO bond and one POH bond compulsory. Okay, essentially both will have at least one P double bond O, one PO bond and one POH bond. The oxoacid in which phosphorus has lower oxidation state, means less than +5 state, contain, if oxidation state is less than +5, then what will happen? Oxoacid in which phosphorus has lower oxidation state, means less than +5, contain in addition to PO and POH bonds either PP bond, as for example H4P2O6, or PH, as for example H3PO2 bonds, but not both. This is the condition. Again I am telling you that in addition to PO and POH bonds, either PP bond or pH bonds they can have. In addition to PO bond and POH, they can have PP bond and pH bond. pH, okay, not POH I'm talking about. Already they will have PO bond, PO and POH. But in addition to that, they can have pH bond also and PP bond also. But not both. This you remember. They can have a pH bond and PP bond, but not both in the same molecule. Okay. These acids in +3 oxidation state of phosphorus tend to disproportionate. This again you remember. It is just like properties. These acid means oxoacid of phosphorus. These acids in +3 oxidation state of phosphorus tend to disproportionate to higher and lower oxidation state. As for example, orthophosphorus acid, or simply you can tell phosphorus acid, on heating disproportionation, or you can tell this disproportionation takes place. Disproportionation takes place, or you can tell disproportionates to form orthophosphoric acid or phosphoric acid and phosphine. A reaction I am telling you, H3PO3, that is the phosphoric acid or orthophosphoric acid. Then H3PO3, it will give this, it will disproportionate and it will give two different molecules, but in both molecules P is there. That's why it is called disproportionation, because in molecules more than one, you can say, P are there. It is forming H3PO4 plus PH3. Then see, now in both molecules P are there, but they have different oxidation state. That's why it is called disproportionation. Okay. Then balanced equation you can write 4H3 PO3. It will give 3H3PO4 plus PH3, phosphine gas. Correct? The acids which contain pH bond, not the pH I am talking about, pH. The acids which contain pH bond have a strong reducing properties. Very, very important question. The acid which contain pH bond have a strong reducing properties. Thus, hypophosphorus acid is a good reducing agent as it contains 2 pH bonds and reduce silver nitrate to silver, means silver nitrate to metallic silver. Only silver means Ag means metallic silver. Then silver nitrate, that is a salt, then it is Ag plus AgNO3 means Ag plus NO3. Then now phosphoric acid has reducing power. Then now silver will take that electron, H3PO4, that will lose electron, and silver ion will take and it will convert to silver metal. Okay, reaction I am telling you, balanced reaction. 4AgNO3 plus 2H2O plus H3PO2. Then now here see, it will give 3 product, 4 Ag. You got silver metal, means now phosphorus acid reduces silver ion to silver, or AgNO3 to silver metal. Second product is nitric acid, 4HNO3, and third product is H3PO4, orthophosphoric acid. This reaction is very important. Again, I am telling you, 4AgNO3 plus 2H2O plus H3PO2, it gives 4Ag plus 4HNO3 plus H3PO4. Now again I am telling you new properties. The pH bonds are not ionizable. Again you understand, POH, then when H is attached to O, then that H will ionize, means it will go in solution as H plus. But if it is attached directly to P, then it will not ionize. pH will not ionize. This is important things. Okay. The pH bond are not ionizable to give H plus and do not play any role in basicity. Only those H atoms which are attached with oxygen in pOH form, when it is attached with POH, then it will ionize and cause the basicity. This is question is asked in every examination. Okay, that pH, why pH are not ionizing, okay, or related to basicity question is asked. Then because hydrogen is directly attached to P, it is not ionizing, but POH, that H is ionizing. When it will be in the pOH form, then that H will ionize. This is ionizable and cause basicity. Thus H3, that H3PO3 and H3PO4 are dibasic and tribasic. Okay, that H3PO3 and H3PO4 are dibasic and tribasic respectively, as the structure of H3PO3 has 2 POH bond. H3PO3 structure has 2 POH bond and H3PO4 have 3. H3PO4 has 3 POH bond. That's why these are dibasic and tribasic. H3PO3 has 2 POH, and so dibasic, and H3PO4 has 3 POH. That's why tribasic. This I have told you about the properties of oxoacids of phosphorus. Now actually group 15 finished. Group 15 finished chemistry of elements of group 15 finished. Now I will just introduce this group 16 elements of p orbitals. I told you 6, that 15, 16, 17, 18. 4 I have to discuss. Then group 15 is over. Now I will give some introduction about group 16. Okay. Oxygen, sulfur, selenium, tellurium and polonium constitute group 16 elements. Okay, these are the elements. What are the name of the elements of group 16? Then 5 are there. Others are also there, but common I am talking about. Oxygen, sulfur, selenium, tellurium and polonium. Oxygen, you know, its symbol is O, sulfur is S, selenium is Se. Selenium is Se, tellurium is Te and polonium is Po. Po. Actually first two is common. Always you will use oxygen, sulfur. Okay, but oxygen exists as O2 gas. Sulfur exists as S8. Allotrope. It actually, these are the exist in allotropic form. Then it exists in O2, S8. Okay. Then oxygen and sulfur is common, but other three are not very common. You will take the name rarely. Okay. Then selenium, Se, tellurium, Te, tellurium. Okay. And polonium. These constitute group 16 of the periodic table. Now, this is actually another important question. Things I am telling you, that question is asked. This is sometimes known as group of chalcogens. Chalcogens, CHALCOGENS. Chalcogens. You can spell anyhow, no problem. Spelling I am telling you, CHALCOGENS. Chalcogens. Correct. Group 16s are called chalcogens also. Why this name is given, chalcogens? The name is derived from the Greek word for brass. Actually in Greek, for the brass they will use this chalcogen. Chalcogen term is used for the brass in Greek. Okay. Then you will ask how it is related to brass. Then here it points to the association of sulfur. It is related to association of sulfur and its congeners with copper. Actually sulfur will be associated with copper. Okay, sulfur will be associated. This points to the association of sulfur and its congeners with copper. Most copper minerals contain either oxygen or sulfur, and frequently the other member of the group. That's why it is called chalcogens. Because it is this sulfur, I told you, sulfur joins with copper. That's why it is called chalcogens. This is the, you can say, brass-like structure, brass-like alloys. And brass is what? Alloy. Okay. Then this I have told you that generally or most copper minerals contain either oxygen or sulfur, and frequently the other members of the group. That's why it is called chalcogens. Now I am telling about the occurrence. Actually, you know that oxygen is found in atmosphere and its percentage is around 21%. That you know, around 21% by volume. That now I am talking about occurrence. Occurrence means that on Earth, how much oxygen is present. Okay, it is in the form of gas, oxygen gas. It is in atmosphere. That is a different thing. But here in Earth or on Earth, how much these are present? Group 16. Then I am telling you oxygen. Oxygen is the most abundant of all the elements on Earth. Most abundant. Oxygen forms about 46.6% by mass of Earth crust. If you will take the Earth crust, if you will consider Earth crust, then 46.6% by mass it is present on Earth or in Earth crust. But in air it is around 21%, 20.8%. Okay. Dry air contains almost 21%, you can tell. Exactly I am telling you 20.946 okay, percent by volume, means you can tell around 21%, 20.946. This is the exact. Okay. However, the abundance of sulfur in the Earth crust is less, only 0.03% to 0.1%, very less, 0.03% to 0.1%, minimum 0.03%, maximum 0.1%, between that. Combined sulfur exists primarily as sulfates. This sulfur in a combined state it is found. Then in which form? Then sulfur exists primarily as sulfate. It is a less actually, but it is found in the form of sulfate, such as gypsum. Question is asked. Gypsum, with formula you should remember, CaSO4 2H2O. CaSO4 2H2O, that is the gypsum. And you should not confuse with a plaster of Paris, POP, plaster of Paris. That is, with that only half H2O is attached. Half molecules of H2O. H2O is less. Thus you remember. Here with one molecule, 2 H2O is attached. But there with one molecule of calcium sulfate, half H2O is attached. Okay, this you remember. That is called plaster of Paris. That is also calcium sulfate only. Then calcium gypsum also is hydrated. Plaster of Paris, POP, is also sulfate. Now another example I am telling of sulfate, that is the Epsom salt. Gypsum is also salt, Epsom is also salt. EPSOM, Epsom salt. MgSO4 7H2O. This question is also asked in general examination like UPSC. In other examination also, every examination it is asked. Epsom salt, MgSO4 7H2O. Baryte, okay, BARYTE, also called baryta solution sometimes. Baryte means barium sulfate, BaSO4, baryte. And it is also found in sulfides form, sulfide, such as galena. Question is asked. PBS, that is called galena. Zinc blend, blende, zinc blend means ZnS. ZnS. Question is asked. Okay. Copper pyrite. Copper pyrite means CuFeS2. Then in everywhere it is in the form of sulfide. Okay. And trace of sulfur occur in hydrogen sulfide. Very less quantity is in the form of H2S. S minus 2. S2 minus you can tell. S minus minus. Okay. Then wherever it will be in the S minus minus, 2 minus, that is called sulfide. Here is H2S, it is the hydrogen sulfide. PBS, then Pb2 plus, S2 minus. ZnS, Zn plus 2 plus, S2 minus. Then always 2 minus is called sulfide. Then traces of sulfur occurs as hydrogen sulfide. And hydrogen sulfide, generally it will come out in the form of volcanoes. Volcanoes. Okay. Volcanoes eruption, that sometimes on mountain it happens. Hilly area it happens. Now organic materials. Organic materials such as egg, proteins, garlic, onion, mustard, hair, our hair, head, hair is there, that hair or any other hair, and wool. Wool contains sulfur. This is the source of sulfur. This question is also asked, it will be helpful. Egg, in egg sulfur is there, in protein sulfur is there, in garlic sulfur is there, onion sulfur is there, mustard oil, what it is, mustard, there also sulfur is there, and in hair also sulfur is there, hair, and wool also sulfur is there. Then selenium and tellurium, now I want to tell you, selenium and tellurium are also found as metal selenide. It is called metal selenides. What is new for you? Selenides, selenium. Okay. Just like other sulfide you are telling, here selenide you are telling. Metal selenide and telluride. Tellurium is there. For that sulfur you are telling sulfide. For the sulfur you can tell sulfide. For the selenium you can telling selenides. Then for tellurides or tellurium you will tell tellurides. Okay, that is in sulfide ores, this will be also present. What about polonium? Polonium occurs in nature as a decay product of thorium. In thorium, polonium is present. This question is asked. Polonium occurs in nature as a decay product, because you know that thorium and uranium both are minerals, but these are the radioactive, hence polonium is also radioactive element, but this polonium will get through decay of these two elements, thorium and uranium. Then now I give an introduction for group 16. Now I am stopping only here, and I will continue in the next class.